This conference will now be recorded.
So good morning team in this Databricks Data Engineer Master Program. So in today's session, we will talk about Spark internal joins, sort merge join and broadcast join we'll be discussing. Okay. So these you can call it as a Spark internal joins or join algorithms that are used in the background. So we will learn types of join algorithms in Spark, Spark join behavior and shuffling the partitions. So how the Spark is going to join the data between two tables or more than two tables we'll discuss. What is this shuffling partitions we'll discuss. Then what is sort merge join, that is the first type of join algorithm which is supported by Spark. Second join algorithm is broadcast hash join. So these two are very important. There is a one more is the hash shuffle join, but which is used very rarely when you don't have a proper data. If the data is not able to sort it, then we will go for shuffle as join, but that is not required to deep dive. We need to focus more into the these two which are commonly used. Okay, now let's talk about type of join algorithms in Spark, right? So if you see types of join algorithms, mainly three types of join algorithms Spark uses internally to optimize join operations depending on the size of data sets and available resources. Okay, how many types of join algorithms Spark uses team internally? Three types.
These steps.
Okay, mainly three types of join algorithms Spark uses internally to optimize join operations. It is depending on the size of data sets and available resources. So how you will decide which algorithm Spark is using currently is, so you need to look at your data size. Second thing is available resources. Okay, size of your data, and the second one is available resources. These two things you need to check. So let's start with the first sort merge join. When you need to go for sort merge join is, sort merge join is one of the most efficient join strategy for large data frames when both data set are sorted on the join keys. If you have a join key which can be used to sort the data, for example, if you have employee table and department table, you generally have a department ID. If you can able to join department ID in both the tables, because in both the tables department ID is the join key, if you can able to sort the data based on department ID, then you can go with the sort merge join. Okay, it involves with the three main steps. One is shuffling, so the data in the partitions on the join key will be shuffled. So first, the in the sort merge join, how the join is going to happen between the employee table and department table is, so first Spark creates a lot of partitions, correct? So within these partitions, first what it does is it will just brings relevant data into the relevant partition. Okay, what is that relevant data into relevant partition? I'll explain. Then we will be talking about sorting the data frames on the joint key. Okay, so once the data is gathered at a single place, all the relevant data is gathered at one place, we'll be sorting the data. Then finally we will be merging those two. Merging means we will be joining after sorting. So these three steps I'll show you practically now. Practically means within the slides also I have taken some example to show you, because if I explain through theoretical things you will not be able to understand. I need to show you those steps with some theory. So remember, sort merge join is going to happen through three steps. One is first there is a shuffling, second is sorting, third one is joining is going to happen. So remember these three steps. Okay, now broadcast join. If the size of one data frame is small to fit it into the memory of each computer, each worker node, then we will go with the broadcast join to improve the performance. Okay, so generally just remember broadcast join is if the size of one data frame is small enough to fit into the memory, so then we will go for broadcast join. Shuffle hash join. If shuffle hash join is the most general purpose join algorithm in Spark, and it is typically used when both data sets are large and need to be shuffled across the partitions. When we can't sort the data, then we will go for the shuffle head join. Okay, there are three types of join. So in this slide, you need to remember only one thing. In Spark, there are three types of algorithm: sort merge join, broadcast join, shuffle head join. As we more focused on the sort merge join and broadcast join, remember sort merge join you will go when you have a two large data sets which can be sorted based on the join key, then you'll go for sort merge join. Second case, broadcast join, you will go when you have a one data frame is small, another data frame is big, then you will go for broadcast join. Okay, so these two, let's focus. Now, within the sort merge join, there are three things are going to happen. First, it is going to shuffle, then it is going to sort the data, then finally it is going to merge. It is going to join the data. Okay. Now, Spark join behavior, right? So, how the join behavior will work? For example, you take employee table. This is the employee salary table. You have an employee table and an employee salary table. Now what we wanted to do is we want to join. So let's say you think of this is P1, P2, P3, P4. Okay. Employee table is having four partition. Employee salary table is having four partitions. Everybody agree, team? Everybody agree. Generally, when you read a two tables, it creates a partitions like this. Now I'll submit these partitions on the worker notes. If you see partition 1, partition 3 submitted here from the employee table, partition 1 and partition 3 submitted on this computer, and this partition 1, partition 4 is submitted on this computer. Remaining here P2, P3, oh sorry, it should be P4, you can say. Okay, so P2, P2, right? 1 second. Small error is there. Just a minute. I'll correct that.
No problem, sir. We can consider as a P3 as a P4 in
No,
B
hold
query.
on, hold on, hold on, hold on. Just take 1 second. You wait. Okay, able to see my screen, team?
Yes, sir.
This is a P1, P2, P3, P4. Four partitions for employee table, four partitions for salary table. Okay. P1 is here, P3 is here, P2 is here, P4 is here. Okay. First table, employee table shuffle, like data is distributed like this. Employee salary table distributed like this. Okay, P1, P4 here, and P2, P3 is here. Now my question is, so generally now let's think of a P1. Okay, P1 means 1 7 10. So this 1 7 10 has to join with the 1 and 7. 1 and 7 is available in the this P3. This is a P3, right? P3. But this P3 is available where? In the another computer. Now, in order to join this 1 and 7 with this partition, you have two options. One is either you bring the data to here or you bring this P1 to here. Meaning now data is moving from one computer to another computer. This behavior is called what? This behavior is called what, Tim?
Shuffling, sir.
Like
Shuffling.
Shuffling is a advantage or disadvantage?
disadvantage.
Disadvantage.
So you know that shuffling is a disadvantage.
Yes,
Shuffling
sir.
is a yes, yes. So shuffling is a disadvantage. Now the thing is, as shuffling is a disadvantage, we need to find a way to join this efficiently, because if you say 1 and 7 is available in the P3, so which is in another computer you are bringing. Again, if you see here, which is a P3, so P3 means you see 2 and P3 means you have 201 and 205. So but 201 is 201 and 205 is here, and if you see here 201 201 is, which is a P4, right? Okay, P4 is also available here, no problem. 205 is where here, that is the P1. So P1 is also here, there is no problem. So P3 can able to join. Now let's take an example of P2. P2 means 2 and 6, right? So this is a P2, right? This P2 is nothing but a 2 and 6. So in order to join 2 and 6, so there is no problem. 2 is here, 6 is here. This also we don't have any problem. Next P4. P4 means 12, 202, 206, right? So if you see 206 P4, and this is P2. So 206 is available. See P2, 206 is here, and P4. P4 means this we are trying to join with this for the 206. What about 202? 202 is here, no problem. 12 is here, no problem. But the thing is, if you have a lot of data where this one partition is here, other partitions are here, then it is very difficult for you to just bring the data and join, isn't it? That is called a shuffling. So whenever you are joining the data, like whenever you are joining two tables, so as I have taken a very small data, so very few cases where we are seeing where data is like joining data is here and here. But you think of a real time huge data will be there. When you have a huge data, what happens? Most of your data will be here, and some of, like let's say 50 100 records we have here and 100 records we have here. Then what happens? 25 records we have here, 25 records we have here, which needs to be joined, because 25 records which supposed to join is not in the same compute, it is in a different compute. Meaning, in order to join these two 25 records, what you need to do, you need to shuffle the data. But as you are aware, shuffling of the data is not at all recommended. So what you need to do, Tim? So shuffling of the data is not recommended, so you may need to handle that particular joining efficiently. So what are the efficient methods we have to join the data is, as we discussed, automatic join, broadcast join, shuffle join, based on the your data volume. But the next important point is, whenever you join these partitions, currently you may have only 4 partitions that you are joining with other 4 partitions. But end of the day, whenever there is a shuffling happened, how many partitions it will create, team, in the output after data exchange, data shuffling? How many partitions it will create, team? Earlier sessions we already discussed, team. Nobody
One
remember?
one partition after
After exchange, after shuffling, how
200.
many partitions are going to create? 200 partitions are going to
200.
create. Okay. Now the thing is, now the question is, which records will go into which partition? There is a formula for that. Formula is the joining key. You can say the partition key means how you will decide which record should go to that particular, which partition out of this 200 is. For example, you have a employee id here. Okay, employee id 2 by 200 is, remainder is 2, meaning it will go to second partition. 205 by 200, it will go to fifth partition. Okay, 205 by 200 means it will go to fifth partition. 6 by 200 means it will go to sixth partition. 206 by 200 means it will go to sixth partitions. 10 by 200 means it will go to 10 by 200 means it will go to 10th partition. 1 by 200, 1st partition, 7th partition, 11th partition, first partition, second partition. So this is 12th partition. That's how it will decide which partition data has to go. So once we have data is shuffled and once it is joined, you will be able to see the data like this. In this slide, you need to only understand that data, whenever we are joining some data, example P1, you consider this is a P1. P1 has 1, 7, 10. Same 1, 7, 10 is available here. 1, 7 is available here. 10 is available here. So this is a P3, right? This P3 is available where? Here, meaning, so 1, 7 of this first table need to join with the 1, 7 of the second table, which is there here, meaning Data has to join from this computer to this computer means either this record should travel here or this record should travel back to here. So which is nothing but a data exchange, which is not at all good for the performance. So we need to find the efficient methods now, if efficient methods to find the like efficient algorithms to do the join in the Spark. We need to find out now. We will discuss. But the very important point, next important point is whenever data is shuffling, whenever data is shuffling, it will create a 200 shuffle partitions. So we need to know how this 200 partitions will bring the data is based on the key column. It will divide by 2 based on the value, based on the remainder it will go into the respective partition. But as you also have seen, there is something called adaptive query execution. What it does is it realize, hey, very small data is there, for this 200 partitions not required, it will bring down again. These kind of things also we have seen in the earlier sessions. Okay, people whoever is joining today's session, I know it is not easy for you to understand him. If at all anybody is there who is attending today's session, okay, 90% you will not be able to understand. Okay, now you see sort merge join. Okay, sort merge join behavior. If you say this is employee ID, employee name, department ID. So I have a department ID, and finally we will be joining the data and getting like this. Now how it will be working is, let's say I divided this entire employee table into the 3 partitions. First 4 records into one, next 4, next 4. Now similarly department data also I divided like first 2, next 2, next 2. Okay. Now, so data is spreaded like this, correct? Data is spreaded like this. Everybody clear? We have seen very clearly data is spreaded like this. Isn't it, Tim?
Yes,
Yes.
sir. Yes,
Okay.
sir.
So as you know, data is spreaded like this. Now the first point is what, Tim, in the sort merge join?
Before sorting, before join, it will be
Shuffling.
sorting.
Sort.
In sort merge
Shuffling.
join, what is the first step? Shuffling.
Shuffle.
Shuffling.
So
Shuffling.
data what it is going to do is internally first it will check. Okay, what it will check here you can see, Tim, what happened is, okay, let me first show you, first let me explain to you, then I'll bring these slides. So I have a department IDs here. If you see 10, 20, 50, correct? Similarly, if you see here 30, 20, 60. If you see here I have a 50, right? I have a 40, 50, 60. If you see here, you have a 40, 20, 60, 10, 30, 50. Correct? Meaning, now in order to join this 20, you have within a same computer, no problem. In order to join with the 10, what happened, Tim? 10 is there somewhere else. So there is a shuffling again. There will be a problem. Next 50. 50, what is it is doing, it has to go here and join. Okay, next to 10 again it has to go here and join, meaning there is a lot of shuffling is going to happen if you go with this. So that's why what we will do, instead of joining data cross like this, right? So the first step in the sort merge join is within the table data I'm going to sort it. Sorry, first step is within the table data I will shuffle it. Shuffle means all the tens I am bringing. See here you have a 10, 20, 50, but I moved the 50 to, so here you can see, right? If you see 20 is there, 10 is there, but 50 is not there, right? Instead of 50 I am seeing here 10. Earlier you see 20, 10, 50, 10 is there, but now here 20, 10, 10, 20 is there, meaning 50, where is 50? 50 I have sent it to the third partition here. Okay, are you getting it? Okay,
Getting,
and
sir.
Yes.
this 50 whatever is there, that I sent it to the third partition, and whatever 20 is there, this 20 that I am bringing here. You see, whatever 20 here you have, right? 30, 60, 20, 30, right? So within this 20 is there, right? That 20 I just, this here, whatever 20 is there, that I just brought it. So meaning in the first partition, two things happened. One is this 50 I sent it to the third partition. This 20 I brought it to the first. So that is a shuffling happened for the first partition. For second partition, what shuffling happened is this 60 I sent it to here, 20 I sent it to here, right? Then I am bringing this 40, 40 to here. Understood? You see here 30, 30, 40 is there. Next, this 50 I sent it to here, 60 I sent it to here, already 60, 50 is there. Now it is having now 60, 50, 60, 50. So how these three partitions are shuffled within the same table, data is shuffled. Similarly, the salary also here 10, sorry, 20, 40 is there. This 40 I am sending to here. Okay, this 10 I am sending to here. See here, 10, 20 is here, 30, 40 is here. Okay, how 30, 40? Because I already sent 40 to here. 30 I am sending from there to here. 60 I am sending to here. Okay, that's how the first step is, there is shuffling happening. Everybody understood?
Yes.
The next step is, so as we have seen, there is a shuffling happen. Next is sorting is going to happen. Sorting means if you see 20, 10, 10, 20, it is not the sorting, right? Sorting means proper order. First 10, next 10, next 20, 20, 30, 30, 40, 40, 50, 50, 60, 60. Like that, data should be in a proper order. Now you see data is going to be sorted. Is it data is sorted now? Within
Yes,
same
sir.
Yes.
data is
Sorted, sir.
sorted.
Sorted.
Within the same table, data is sorting. Here you need to understand within same table. Okay. Once the data is shuffled and sorted, now you think if you go with the joining now, it will be easy for you. So at the time of joining, shuffling is not going to be there. Correct?
Yes,
Shuffling
sir.
is not going to be there. If you can able to sort it now, you see if you join now, there won't be any like a shuffling at the time of joining. So because joining is huge table, you are joining with another huge table, which is very costly operation. That's why before you make that join, first you shuffle, then you sort it, finally you join like this, so that your join shuffling will be reduced drastically and it improves the performance. Everybody able to understand?
Yes.
No. Next, sort merge join behaviors. If you see, this is the executor one, okay, and this is that is employee table. Below is the department table. So what happened, Tim? After sorted, we are just joining. So when you join, what happens? Against that department ID. So for example, 10 is a HR. So HR is coming. So marketing means marketing is coming. So data is joined, and you will get the data like this. Finally. Okay. Now let's talk about a broadcast join. Broadcast join is you need to do lit. So how it will work is, just to think of this way, team. You have an employee table with the three partitions. Okay, three partitions. And what happens? This partition in one computer, this is in another computer, this is in another computer. Okay. You already have seen at the time of joining what happens if you have a shuffling. It is not good for the performance. We have seen sort merge join. But now my next question is, in the sort merge join, what happens even though it is shuffled, sorted, finally data is in a multiple partitions. Multiple partitions means, let's think of this way, team. You have uh, here 1, 2, here you have 1, 2, here you have 3, 1, here you have a 3, 4. Okay. Now you think of here 4 and 5. You have here 1, 2, 4. Now what happens, Tim? When you join, so this one has to join with one and two has to join with this two. Again, this one has to check with other partitions. This is matching with this or not. Okay, one is going to match with, because here you have not sorted the data, right? In the sort merge join you have sorted. So if the 10 is not matching means it is no longer will be there. Are you getting? Because in the sort merge join 10 is not there means, I mean to say, for example, you started joining 10, 10, 10, but suddenly 20 came. Meaning after joining with the 20, there is no chance that 10 is going to be repeated again in the sort merge join, isn't it? Because data is already sorted. All the 10 should be there at the first only. If 10 is not matching anymore means it is not going to be there further. I no need to check for the 10 whether is it joining with other partitions or not. Correct?
Yeah.
I know. I know definitely it is very tough to understand. A lot of internal things are there, but you see how much you can understand. Okay. So here what I'm trying to tell you is, see, one is there, one is joined. If one is I joined with the two, which is not matching, but it doesn't mean that one is not going to be matching with the other data, right? Correct or not? It can match
Yes.
with other partitions because data is not sorted here. Data is not sorted. So one can be there somewhere else. So I need to join each partition of this, need to join with all the partitions of the another table. Correct?
Yes, sir.
But do you think of a scenario where, okay, you have a three computers, right? This is a partition one, partition two, partition three. But this is a big table. I created a partitions. But other table is a very small table. Instead of partitioning entire table data, I have kept it in this computer. Entire table data, I kept it in this computer. Entire table data, I kept it in this computer. Now what happens, Tim? Now whatever data is there in here, it should match with all the IDs that are there here. If something is not matching means this is not going to match with this table any longer, because this table entire data I have here. Here also if you take the entire table data is here. So if you take this partition, entire table data is here. So let me just go back and come back. Take this as an example. You have a partition 1 and a department table partition 1. Okay, employee table partition 2, department table partition 2, employee table partition 3, department table partition 3. Now what happens is this 10 is joining with 10. So with this is the same computer, right? First partition, this is the same computer. See, so this is the one computer team. This is the second computer team. This is the third computer team. Okay. Now my question is, within a first computer, 10 join with the 10. 20 is not matching with 30. It doesn't mean that 20 is not having a respect to department ID, right? It can be there in some other partition. So again, you need to take this entire data. You need to check with other partitions. Okay, when you check it, this is basically matching with this. There is a data shuffling, isn't it? There is a data shuffling, correct? Because some data has to go here again. Next to 30. 30 you joined here, it is not matched. It doesn't mean that it is not there. Department is not there, right? You need to join with other partitions to see. Here it is there 30. 40, if you see 40 is there in other partitions. So there is a shuffling. To avoid this shuffling, what I am saying is, you think of this. This is the employee table is big table. You created three partitions. Okay, in every computer, this department data is small. You copy this data in all the computers, three copies. Now 10 is joining with 10, 20 is joining with 20, because all this data is available in this computer. No shuffling is required. When it comes to 30, 40, this 30 joining with this, 40 joining with this, because same copy also available in the second computer. And 50 joining with 50, 60 joining with 60. Why? Because same copy is available in the third computer as well. Are you getting? Meaning, when to go for broadcast join is, when you have a big table, when you have a small table, this small table can fit it into the memory. then you need to go for the broadcast join. Everybody understood here what I was saying to you?
Yeah.
Yes, man. Yes.
Yes.
Someone can you explain what is broadcast join, because very important interview question also.
Yeah. So broadcast join is one of the join strategy algorithm. So when we are joining with the one big table with the small table, so with a minimum of 10 MB, we can keep it. That is a broadcast join table that will store into the all the partitions where has been stored in the all
All
the nodes.
worker nodes.
Yeah, all the worker nodes. Then it
All
will automate. Yeah, without shuffling, that will join in the partition itself.
right. Correct. Okay, Tim. Clear? I know it is not easy for everybody to understand. Now you see large data set. So we have created a partition 1, we will keep it here. Partition 2, we will keep it here. Partition 3, we will keep it here. But small data set, whatever is there, that small data set, what we are going to do is we will copy small data set to here. You can just think of, okay, we will copy that small data set to here, here. Okay, getting Tim?
So I have a question here. So you
Yes.
said the Spark will consider minimum of 10 MB, which can be stored in the memory. So what
Mm.
happens if it exceeds 10 MB?
Then it will not consider as a broadcast join, it will go for short merge join. But if you want to, you know that it is a 15 MB which can be fitted to the memory, then you need to change the Spark configurations. That also will be, I'll be showing you today. Okay.
Okay, okay, thank you.
One question in a short
Mm.
match join. So as we discussed, we are joining on a single key. That means employee ID. Uh, so our department ID. So instead of that, if you have the multiple join condition, so that we how we can consider to make it shuffle before join.
Okay. So to make it as a join, what it does. Okay, so the sorting, right? Sorting is going to, like a shuffling and sorting is going to happen on based on all the columns that you have. It is not that you have to have a single column, right? In real time, you may need to join based on multiple columns. If your single column can't make it as a unique for joining, then you will be joining with the multiple columns. Based on all those columns, it is going to do the shuffling sorting. Got it?
Yeah.
You can
Okay.
sort, you can shuffle based on multiple columns also, right?
Mm-hmm.
Yes. It will go in that way. Any other questions, Tim? Okay, next. Come here. Now you see, Tim. Oh my God, already 6:40. I'm just attaching this cluster. File store slash tables. I'm checking. Okay. It is removed if at all anything is there. Now I am checking is there anything under file store slash tables. Nothing. Pip install faker. I'm installing a faker module, Tim. So this faker module I am installing is this faker module I am using to generate a employee ID, first name, last name, email, department ID, job title, salary. So I want to join. I want to generate a rows needed is two lakhs records I am generating. That 2 lakhs records. Okay. I'm creating a pandas data frame, and pandas data frame is a, you can also create a data frames within the python, so which are not distributed, which will run in a single computer. That's why it is slow, but still in this case I can only create a pandas data frame. So pandas data frame I'm creating, and I'm saving that particular data into the local storage only. You can able to store. you can write the data into the local storage from pandas data frame. You can't write it into some our data lake blobs and all. So that's why first I'm saving the employees data into the local directory. So how many records we are generating, Tim?
Let's
Remember, we are generating the 2 lakhs employee records we are generating. Let's wait for a few seconds. It is generating, Tim. It may take 1 or 2 minutes. Okay. It took less than a minute. Now ls/tmp, you see employee.csv file is generated into the local directory. Now I am reading that. Okay, I am moving. How to move this particular local directory into the Databricks file system, or in the latest Databricks community, you need to move these files into your volumes. Okay, you need to create your volume and you need to keep the files. So that also I'll show you if we get a time. Otherwise, we'll see in the future sessions. So you can move these particular files into file store/tables. So once the file is moved to file store/tables, I'm just checking here. So employee.csv file is available. Now I'm reading this employee. Okay, so you see the size of this particular file is this. Okay, I'm just looking at first it's a bytes. I'm converting into the KB, then I'm converting into the MB. So now whatever value you are seeing is a MB. Now employee file, what is the size of the employee file, Tim?
12
11
MB.
11
MB,
MB.
11.8 MB. Okay. Now I'm reading the data and I'm going to show you the data first for the employee table. Let me show you the data. So you can see, right, employee ID, first name, last name, email ID, department ID, job title. You are seeing salary data is nicely generated, 2 lakhs records. Okay, if you want to order the employee IDs, you can even order the employee IDs. You can see employee IDs. Fine. Now, the next question is, if you see department ID, one second. So department ID is random. Now it is just so these are the department IDs are generated. Okay. Now the question is very similar to that department table I need to generate. How many records I'm generating, Tim? Department ID name, manager name, location,
Alex.
budget, account start data, 5 lakhs. So I'm again creating a 5 lakhs records for the department table and I'm writing into the local directory. It will take approximately 1.5 to 2 minutes. Tim. 1.5 minute to 2 minutes it will take. Let's wait. Once the file is available, I'll move it into the again file store. Then I'll list down. Then we need to calculate the size. Remember, what is the employee file size, Tim? What is the employee file size?
11.8
John,
11.86 MB.
11.8 MB. Remember these things because you need to know when we are applying the join based on the size of the size of the table. It will take the different joins. Okay, so we have broadcast join and sort merge join. One of this it will take mainly. So I'll explain to you that. Okay. Is it done? Yes, the department table, it took approximately 2 minutes, but I'm moving that file into the file store slash tables. If you see, there are two tables. Earlier we moved employee table, now department table. Now this same table size, I'm trying to get it. Now department table size, if you see, 28 MB, correct? Now I am reading a department table and I am showing you the data first. After looking at the data, you can also get the counts. How many records are there in this data frame? You can be able to get it. How many are there, team? 5 lakhs. Now, need to move this at the last. Because every time that right now. Okay. Now, first thing what I am doing, adaptive query execution, I am making it as a false. Because if adaptive query execution is there, it will take care of a lot of things internally. So we will not know the actually what is happening, right? So that's why employee table I am reading, department table I am reading, and I'm just simply applying the join. You know the join syntax. Employee table join with department table based on department ID. Type of join is inner join. Just execute. What is the join algorithm it is going to take in the back end? The question to you.
Short image join.
In sort merge join, what all steps are going to execute?
First shuffling,
Shuffling,
then sorting,
sorting,
then after that it will
join,
join
merging.
based on the joint.
Shuffling,
Sort.
sorting, joining. Correct? Let's see same things are happening or not. Click on job 9. Job 7, 8, 9 are created here. Job 8, 9, 10, right? Now you need to see these are stages. Yeah, this is job 8, right? Do one thing. First thing is click on this cluster, go to Spark UI. These are the job IDs 7, 8, 9. First go to job ID 789. Out of 789, the job which took more time is this. Let's click on this. And within this, if you see, there are three stages are there. There are three stages are there. If you look at the DAG visualization, you can see it is reading the employee table, reading the department table. Immediately there is a exchange, sorting, then there is actual joining is happening. Okay, there is a exchange is happening, right? There is a exchange, then there is a sorting, then finally joining is happening. So same thing, you can also go to SQL slash data frame. Job ID is 789, right? 789. This is the job which took more time. If you click on this, in the data frames also we can visualize what is happening. There is a CSV files. There is a filter happened because it is just a safe side. Department ID is the key column. It should not be null. If at all any nulls are there, it is just filtering. Is not null, is not null. It is taking. Then it is shuffling, then it is sorting. After sorting, it is joining. After joining, it is just selecting and showing you the data. Okay, so whatever we discussed through the theoretical point, I have shown you what is happening in the background, and I have explained to you 3 steps. Same thing is happening here. But why you took sort merge join? Why you did not take broadcast join?
Because
Sir,
of the
because
size.
of huge data, sir. Because of huge data, Spark automatically it will take a small so, short measure.
Remember, broadcast join. Go mute, Latish. So broadcast join, remember team, will be applicable if it is a default size is 10 MB. Meaning if one of your data frame is, sorry, one of your file is 10 MB or less than 10 MB, other data frame, other file can be any size, but at least one file is less than 10 MB, then because the broadcast join is going to be applied on a one large data set, one small data set. A small data set, if it is less than 10 MB, by default it will take the join. You see now, so I'm taking what is the auto broadcast threshold. It is saying 10 MB. 10485760. I divided by this 10 MB. If it is a 10 MB or less, it will automatically apply the broadcast join. But our files is 11.8 and 28 MB. Both are above 10 MB. That's why auto broadcast is not happening. If you want to set them to the like much more higher, right, maybe up to 20 MB, you can set it. Okay, but if you don't want to set it, what you can also do is you can read the employee table, department table. You know that so department table is bigger, but still you want to broadcast the department table only, then you can say employee table join with broadcast of, say broadcast is a function, so that using that function we have to apply broadcast of df underscore da, df underscore dapt. Now you try to write the data into some target.
So do we need to explicitly call this broadcast function in order to do the broadcast join?
I just now told you, right? Auto broadcast will be applied if you no need to say like this. Auto broadcast will be applied if the size of one of the data frame is less than 10 MB. But our both the data frames are more than 10 MB. That's why automatically broadcast is not applying. In order to apply the broadcast automatically, we need to do two things. One is you may need to do like this, you need to specify, or second way is you need to set the threshold from 10 MB to 20 MB or something like that. Based on, for example, if you make it as a 20 MB, it knows that one of our data frame is 11.8 MB, it will be broadcasted automatically. Understood?
Yes, yes, thanks.
Now you see this is a broadcast applied. Now click on this. No need to go, right? We have a Spark UI opened here. Now you can click on again SQL slash data frame. Okay. 10, 11, 12, 13 are the job IDs. 10, 11, 12, 13, which took more time. 12, 13 go inside this. Here you can clearly see department table we are reading. We are taking not null records and it is broadcast exchange. What it is doing, it is just catching, it is putting this particular data in all the computers. It is broadcasting. Employee table side also, employee table we are reading, we are taking not null records from department ID, we are joining these two tables, then we are selecting the columns and writing the data into the target. Clear? Okay, that's how broadcast join you have to apply. Now the next question is, for example, just a minute, I'm just listing down. So whatever files we have is the department and the employee. But whatever files I am referring here is employees departments. Okay, meaning I need to go to catalog, go to create table. I have very small employee and department files also. This is session number 45, right? 45. So employees departments. So if you see the size of these two files are 1 MB, sorry 1 KB, 4 KB, not even 1 MB, very small files, right? Now let's see, I'm not using anything, right? I'm not saying you broadcast it. I'm not saying you broadcast it, but it is reading a 1 KB file. Both are 1 KB files. Now I'm just joining. Now let's see which type of join it will take in the background. 14, 15, 16, 17 are the job IDs that I need to go. Click on that compute. Directly you can go to Spark UI, open a new tab, you can say. Any way you can do. But if you see SQL slash data frame, what is the job it is? 14, 15, 16, 17. Okay, 16, 17, which took more time. Go here. Broadcast is applied automatically. You understood? 27 records are there in my, I think here also it's a department table. This is an employee table. A department table only, it is broadcasted. Everybody understood?
Yes.
Okay, automatic broadcasting is applied because the size of the file is less than 10 MB. Okay. So if you want to disable the broadcasting, you can use a -1. When you apply a -1, okay, on the see now I disable the broadcast. Now I am executing. So when you disable the broadcast, you are clearly saying don't use broadcast at the time of joining. Then what join it will prefer to use now? What is the next join it
Sure.
will prefer to use? Sort merge join. Let's
Short
see
merging.
that. 18, 19, 20. SQL slash data frame. 18, 19, 20, 21, 22, 23. Okay, go inside this. Here you can see that scan, filter, exchange, sorting, and joining. You understood? See 27 records it right here. 50 records from employee table, 27 records from department table. But with very small data also sort when it is applying. Getting so the finally there is a something called broadcast variable also will be there. Team. What is this called? Krishna, your voice is breaking. Is saying. It's same for all of you. Team.
Yes. Yeah.
Yes, sir.
It's same. Is it breaking still?
Still same, sir.
Yes, still breaking.
1 second. Looks like your network is fine. Able to hear me now?
Yes, sir.
Hello.
Oh, it's fine.
Yes.
Is it breaking?
Now it is fine, sir.
I think now it's
Okay.
fine.
Okay. So now you can see, right? This is a department table D. Oh, sorry. This is not department. This is a variable. You know, right? What is this variable? What is the data type of D?
Sir,
Dictionary.
this is dictionary, sir.
It's fine.
So broadcast variable means D is a variable which is the dictionary. That dictionary I want to broadcast. So you can also broadcast. SC is nothing but a spark context dot broadcast of D, meaning I am storing this variable in the memory and I am developing a one function. If anybody asks for employee ID, if somebody passed the employee ID, I'm going to return them their employee name. Okay, that's what the this function. What this is doing from this particular broadcasted data, it will take the values. From the values, it will see okay, user is asking for this particular employee ID. What is that value? So 7058 employee ID means name is Rama. It returns a Rama. So that's why I developed a function. Now, first example, what we are doing sc.parallelize. It's a RDD I'm creating with two employee IDs, and I want to get the employee names, respective employee names. So what I'm doing, I'm using a map function. Within the map function, you know, it will take another function. Map will take another function, right? So this function I am giving for the map. So map will map responsibilities, take these IDs, pass this to the this function. What this function does, this function, go muting. This function brings the data, and this function takes this particular employee ID. It will query on the broadcasted variable to get respective employee name. 7058 means Rama, it returns a Rama. Next 7072 means Krishna, it returns a Krishna. So here we know that male employees are given, here female employees are given, so it will bring the data. Yeah, anyhow we are done, team. That's all for today. Please let me know if you have any questions. Hello. Able to hear me, team? I don't know why it is like this. It is showing very high speed. I don't see any network issue. I think the GoToMeeting might have the issue, or I'm not sure about that. But the network seems to be good from my side. That's okay. But able to hear me, able to understand this. Anybody have any questions still here?
Oh, now I can hear you.
Yeah, I'm asking. Anybody have any questions still here?
Sorry, Malay. Actually, because of this issue, we couldn't. I mean, I couldn't hear your voice.
Okay. So till where you heard about it?
So we were good till
Function.
the get
Function.
employee name function.
So function we developed to read the broadcast variable values, right? Now what I'm doing, a user has given a employee IDs. These employee IDs I'm passing to this function using the map transformation. Using map transformation, I'm passing these employee IDs to this function. What this function does is this function fetch the respective employee names. I am passing the employee IDs to the function. This function returns employee names. So now you see male employee names are Rama Krishna, female employee names are Ganga Lakshmi, something like this. Okay, this is called broadcast variable. I mean to say you can able to broadcast the variable, you can able to broadcast the small data set. Meaning the small data frame you can able to broadcast, this variable also can be broadcasted. Understood? Any other question?
Hello.
Hear me now? Able to hear me now? Hello?
So
Yeah,
now your voice is coming through.
yeah.
Okay.
So, okay, if possible, could you please explain that accumulator as well, if possible? Not today.
Accumulator will discuss
Yeah.
later.
Okay.
So
So
broadcast,
connected.
I'm explaining once again, team. This is a broad variable I have taken. I am storing in the memory, and I am fetching the values from that particular broadcast variable by using this function. And this particular function I am calling by using the map transformation. So here employee IDs are given. Those employee IDs I'm passing to this particular function to fetch the values from the broadcasted variable. So you can see the values. Okay.
So, so in the map, the function you are passing on that this ID you are not passing, only function name you are passing.
So map transformation is responsible to pass this employee ID to the function. Internally, it will pass. It will not be shown explicitly. So
So
one
let's
by
say
one
this.
employee
So
IDs will
let's
be.
say in the function we are passing the multiple parameters, employee ID and some other the second parameter. Then how I
Hmm.
will pass here?
So it is based on what this function is defined. If this function is defined to get multiple values, then you can able to send a multiple values. Okay. As you see here, we know that this takes only single employee ID. We are passing one by one employee ID here. So based on how your function is defined, what parameters is expecting, so same parameters you need to pass at the time of passing from here.
So
Now map,
employee ID and employee name. Let's say these two parameters we want to pass on that function. Then how I will pass here? Now you are giving the 7858 like that.
you need to pass like this. And I'm just showing you
Employee
employee
name.
name. You just pass it like this.
Okay.
You need to change the return type as well, right?
No, return type is not mandatory. Just a minute. First, is it failing? Because here we are passing only one. I want to check there. Okay, job is aborted. Okay, so I'll tell you the way how you can able to pass is employee details. Print employee details. You are passing as a tuple, right? Maybe you can just say 0th argument because which is employee ID. How it should work. Yes. Now you see what we are doing. We are sending all the values to a single uh, like argument from here because the single argument contains actually multiple values, right? Employee ID and employee name. So as I need only employee ID, I am using it. If you want employee name, you can use it within your function. Understood? Clear? Okay. So that's all it for today. Team, please let me know if you have any questions.
Sir, can you provide the Python script for file generating, sir?
Yes. I'll share in group. Okay. WhatsApp group.
Okay, thanks, sir.
Any other questions, team? Anybody have any other questions? Who asked this doubt, team? Here, whoever asked this doubt, are you clear or not? You have to respond. Okay, fine. Any other questions, team? Anybody have any other questions?
No.
Okay. Thank you all. That's it.